Alright guys, in this example we're asked to find the prime factorization of the number 1073. So we're going to use a result from our notes that says that the prime factors that we have to check, we only have to check up to the square root of this number, right? So we only have to check the primes that are less than or equal to the square root of 1073. So let's start. I don't have a calculator. We're going to do this all by just by brute force. So let's start by approximating this number, the square root of 1073. Now, notice that 32 is equal to 2 to the 5th power, and so 32 squared is equal to 2 to the 10th power, which we know is 1024. Probably one of our favorite numbers if we're computer science majors, right? 1024, number of bits in a megabyte, you might say, bytes in a megabyte. But anyway, 1073, yeah, is a little bigger than this, so we're not quite there yet, but 33 squared is going to be even larger, right? So 33 squared is going to be even larger than this. So we don't care exactly what it is, but 33, by the way, 33 is not a prime number anyway, right? But this is going to be larger than 1073. The smallest prime number, sorry, the largest prime number that is smaller than this number, right? Our number P that we have to check. So the largest prime that we have to check is then 31. So the largest prime to check is 31. That doesn't mean that it's the largest prime number factor of our number. It just means that if there's a prime number larger than this, that is a factor of our number, it must be multiplied by, so it must have a companion factor that's smaller than 1024. Alright, so that's why we have to check that. So let's make a list of all the primes less than or equal to 31, and then we can start checking them. The checking is just an exhaustive thing, right? So the primes are 2, 3, 5, 7, 11, 13, 17, 19, 23, and then 29, sorry, almost missed one, and then 31. Okay, and so these are all the primes that need to be checked. We could either start from left and work our way to the right, or we can start from the right and work our way to the left. These ones on the left-hand side are easier, so you can, some of these have tricks, like 2 through 11 all have tricks that we can check them with. But honestly, I think we're better off to start from the right and work our way back. So let's see. And for this, we just do brute force division. So let's see if any of these numbers are divisors of 1073. So let's start with 31. 31 into 1073. Well, 31 times 3 is 93. And then we subtract, we get 143. And then there's no way, the only way to get a 3 as the last digit is to multiply by 3. And that only gives us 93. We already checked that, right? So this would actually be probably a 4 with a remainder. The point is 31 is not a divisor, so that one's off the list. We go to the next one. We'll check 29 now into 1073. So this one will probably go in 4 times. So what would 4 times be? So 4 times 9 is 36. 36 plus 8. No, 4 times is too much. So only 3 times. So this one's going to be, 87. All right, so 87. We subtract, we get 220, and then we drop the 3, so 203. And then we want to see if this goes in. So to end in a 3, it would have to be a 7, right? Because 7 times 9 is 63. And then what do we have? 66 plus 14 is 203. It's exactly right. So it goes in perfectly, right? So there we go. So we've got 2 things here. Number 1, 29 is a divisor. Okay, it's a prime divisor. Number 2, the quotient, when we use the divisor, right, the quotient is 37. 37 is prime, right? 37 is a prime number. It's larger than 31, but it is a prime number. And so what this tells us then is that our number 1073 is equal to 29 times 37. Boom, that's it, right? We're done. Now, that means we don't even have to check the rest of these, right? Because we already found our prime factorization. That's our answer. What's the difference if we start on this end and work our way up? Well, we just get a whole bunch of no's, a lot more no's, right? Not a factors until we get to 29. So you're free to start from this side. It's clear that 2 doesn't work. There's a trick for 3. You can add up the digits. The sum of the digits is not divisible by 3, so that's out. 5 is done by inspection, right? So it doesn't end in a 5 or a 0, so that's out. There's tricks for 7 and 11, and then the rest you just have to do brute force. But just by chance, I didn't know the answer, but just by chance I got lucky by working from the big numbers backwards. Okay, so that is a method for finding the prime factorization of a number. First, find the largest prime that you need to check, and then just start checking by exhaustion until you get your answer.